Good day, ladies and gentlemen. Today I'm going to show you how to open shapefiles in QGIS. So when you open your QGIS file, select a new project. I've already done here, and then you will have a blank screen. First step would be to add or open a new data source. Go to that icon. The shapefiles are in a vector format. Select these three dots over there, and then once it's open, go to your shapefile. In this case we had the files as 2430DA and DB, various ones of them. So I'm going to select the .shp, make sure all four files as listed there, the DBF, the PRJ, which is your projection file, shapefile, and the SHX are all in the same folder. Very important. Select it and then just add it and close your data file. Then if we want to make sure that we are in the correct position, just add your OpenStreetMap also down to the bottom. Select the relative position of them, and then we can see more or less we are at the correct position in this case, so it corresponds with our existing geometry and topography. The next step that we would want to do from here on is to create a raster file. Now for this step we want to interpolate all the contours. What we will do is we would go under View, select the panels and select the Processing Toolbox panel. Once the Processing Toolbox panel is open, then we will go under Interpolation, select Thin Interpolation, execute it. We will select our first file as our input file. We want to interpolate the elevation, use the Z coordinate for interpolation, add it and select just points as the general one. Then up the number of rows. This typical section here is around about a few kilometers. So how many rows and columns do you want to interpolate in? For this case I'm going to select 1000. The columns will automatically be calculated, and I will ask it to run the interpolation. Sorry, I missed the extent. Obviously the extent must be exactly the same as our input file, and then we would run it. And great stuff. There we've got our topography nicely integrated. So now we can repeat the step for all the other contour sections, and at the end merge these files together to create the whole topography as required. I hope this is of value for you, and good luck with your assignment. I've repeated now the step for all four data sets to create a raster for each one of them, as can be seen here. Now I want to combine these four raster sets into a single raster. So I'll go under my setting, raster, and then under miscellaneous and merge. As an input file, I would select all four of them to be merged into a single file, and I would leave all the default values. You can specify this optional data set as no data as -999, but it shouldn't make too much of an issue for you if you don't do it. And then we would run the analysis. Takes a second or two. Once it's done, you can close it, and you can see now all four of them have been combined into a single raster set. Now I've plotted my four points where I need to supply the water to, as indicated in Google Earth, and I want to get my recommended pipe route. So I would start off, here's the dam, more or less, and then there's a main road that travels all the way to farm number A, B, C, and D. So depending on what your choice would be, I'm going to start off with a single pipeline from the main dam. To start off, I'm going to create a path starting on the eastern bank of the dam. I will add my route, and this will be different for each group, because you need to decide where your pipe is going to be. But this is just a general example. You need to determine what's the optimum for your project. So I'm going to supply one pipeline to farm number A. Here go. And then maybe I will just have a offtake going to farm number A. So I'm going to proceed actually along the main route, because I think this maybe that was too far. I'll proceed up to here and then go on to this gravel route so that I can have offtake to farm number B. Maybe go straight here on this gravel route, and then we can supply with offtake to farm number C, and then somewhere farm number D is still further on, but I'm just going to stop here. So this is my proposed route, my bulk route. So I will name it accordingly and then store it. Next, I will save this file, save this place as a KML file. There I will overwrite main pipeline, overwrite my file. In the next step, we want to import this route now into our QGIS so that we can get the elevation profile. Because if we show the elevation profile here, obviously it's not as accurate, and we can't export the data. We don't know the XYZ coordinate system for this. There are ways that you can do this. You can go that route if you wish to, but the coordinates after contours was already provided to you, so you can do a better assessment. Okay, so we jump back into QGIS. Let me just open QGIS for us. Here we are. Okay, we've got our full raster file. Next, we will add our KML. Again, it's a vector file that we will add. KML, open that main pipeline, and we will add it and close. And there we can see, here's the pipeline as we had it in Google Earth, similarly. Now we want to create points all along this route so that we can extract the elevation. So we would select our file and go under vector creation and select the option that says generate points, pixels, centroids along line. For this one, double click and we will select our raster as our base, which would be the merged file. Select our vector file and we can just leave the rest as temporary files to generate it. And we will run our analysis and close, and there we see all these points. You will see it always plots it to the center of this small square, because that's the option that we selected. So it's a little bit jagged to the left and to the right, but if you refine your squares, use a smaller or more rows and columns, then these lines will obviously be closer. But for the purpose of the assessment that we are doing now, this will be sufficient. Okay, next we will export these points along lines that we've now generated. We will right click on it, say export, save feature as a CSV file at the top. Make sure you select that. Then select appropriate name. Let's call this XY plan view just 1, because I've already exported it previously. And then make sure you select UTM zones, otherwise it will use degrees for latitude and longitude values. Under the geometry, select points, include Z values, select under the geometry XYZ again for the layer options, and select OK. There we've got it now as exported file. Then we want to export also the Z values, because unfortunately in this manner the Z values aren't accurately exported always. So we go under the plugins, manage and install plugins, and under the all option, enter point sampling tool. This only one will come up. You need to install it, select it and install it. I've already installed mine. So once it's installed, then you can close it, go under plugins again, and then under analyze and point sampling tool. Then you would select your points along line that we've got. That's the only points file that we've got in our layers, and we would like to export it in comparison to the merged raster. And next we would create the file, the path to the file. So we go to the same folder, temporary, and make sure CSV file again. Or again, I have already exported it, so I'm just going to call it number 1 and then save it. And once we've got it, then we can export our files. It's easy as that, ladies and gentlemen. Let's continue. Okay, there's my 2 files that I've exported. I can open them in Excel as I've done over here. So the first one was the Z coordinates, only the Z elevations. I can see I've got 789 unique values, and then the XY plan view coordinates, as we can see, similarly 789 unique values. Now I would go to my Z values and copy them, paste them into my file here. First, we want to calculate now the individual pipe length between each coordinate. So we can say pipe lengths in meters, and that would simply be Pythagoras that we apply. So let's call x squared plus minus squared plus minus squared. Take the square root of all of this. And the nice thing is, because we've used UTM zones, UTM coordinate system, everything is in meters. So let's just see what's the problem here. This one must be squared, and everything square root. 37 meters between those two coordinates. So we can take it down. You can see most of the points will have more or less 37 meters because they were spaced equally along the pipeline, more or less. The next step will be to calculate the pipe chainage, and the pipe chainage, remember, is only the horizontal distance. So for this case we will use only the X and Y coordinates. So I would copy this, paste it, and remove the Z coordinates. So this is the horizontal distance. Now, in the next step, this is individual values. So we start at chainage 0. Next one would be 0 plus 37. And take it down all the way. So my pipeline, the total length on the horizontal plane is 23 kilometers, but the actual pipe length will be 23,700. So a little bit of a difference because you go up and down the valleys. Now we want to plot this in a plot. So we can go under data, insert XY plot, select the data, add pipe chainage, X values would be my chainages, and the Z values will be my elevations. Okay, let's see our plot, and perfect. There's our first profile. So we can change the minimum value, just find, see there, to 500, and there we can see. So on the left hand side, remember to name your axis, or the axis. This one would be your Z values. So Z elevation in meters, and this X my pipe chainage. Good. Ladies and gentlemen, now you can repeat this for each individual pipe segment that you have, and this can be now imported into your EPANET model. Next, we want to import this now into our model as a accurately georeferenced EPANET model. So we would first start off just by putting in an arbitrary reservoir, and let's add 2 or 3 nodes. We will add our pipe segments, and that's it. Next, we would save our project, save as, desktop, temporary, and save your project file. Then we would export this network as an IMP file and save your file. We will go to our folder, we will store this. The IMP file can be opened in Notepad, and there we see each one of these individual components. We've got our pipes and the junctions, reservoirs and junctions. Now we want to modify this IMP file so that it's applicable to our system. So we would copy first these coordinates, go to our Excel spreadsheet where we had it, and paste it. There we've got XYZ and our reservoir. Let's move our reservoir just to that side and choose all our XY coordinates. So here we paste them over there, and we need to add some junctions all the way to the bottom. Then check our reservoir. Our reservoir must obviously be at the highest elevation, so that would be at 648. So the first line represents the reservoir in our case. So I will change this junction 1 to start one line lower. And delete the last one, go up and add this as my reservoir. Okay, now I will go and copy. These are my coordinates. Let's name it like that. Coordinates. For my system. And then I would go into my IMP file. I've selected, just double check everything under the title. Paste it in the same way, everything under the title. And there we've got it. Don't worry too much about the spacing, as long as there's a single space between each individual value. Next is the pipes. The pipes, we would copy again from the IMP file, rename it as our pipes, and paste it in. Okay, pipe 1 of 10 starts from the reservoir to the first node. Pipe 20, 30, 40, etc. So go to our coordinates, select pipe top one, and we will paste it in there. Next one, start just from the opposite value. Then we jump all the way down. The pipe lengths we've already calculated, so we can go to our pipe lengths column. There's our pipe lengths for each individual pipe, and let's paste it as values, and we've pasted it now in. Go to the lowest line, last one, removed, go up. I'm going to start off with 800mm pipe throughout the system, and we leave everything as default. Select all these data, copy it, and paste it into our IMP file. There's our IMP file now pasted in. And then the last one would be to have all our elevations assigned. So elevations, which is according to the junctions. Let's create a new one, rename junctions. We add our junctions in there. We will go to our coordinates again. select all the coordinates, paste it, and then go to our elevation column. Remember, the top one is the reservoir. We copy everything else from the bottom down. Paste it, make sure, yes, that's fine. And the demands for now we leave as 0, so we copy it. Okay, next we will take this, copy it all the way down to the bottom. See this line column, it needs to be 0. Obviously Excel has started counting. The demand must remain 0. So we copy all of this, go to our INP file on the junctions, paste it in, remove the extra line there, save it. Now we can open this file in our EPANET. So let's start a new file. No. And I want to import a network. There's my INP file that I've created. I will open it. I will go under View, Dimensions, ask it to auto size it, select meters as unit map units, and voila, there we've got it. Now you can turn on auto length if you want to make any modifications to this, and then you can zoom in. Let's put the base demand here at the end for this farmer as, for argument's sake, 500 liters per second. Then we will run our analysis. Let's see where's the problem. Okay, so we see we've got an error with pipe number 70, pipe number 110, 200. So let's go and open our INP file and see where that issue might be. We open the INP file, pipe 70, let's go down to the pipes. Pipe 70, the length is 0. That's the issue. Pipe 110, the length is 0. Pipe 200, length is 0. So that's where my issue is. So I will go to Excel. We have got my file, working file, under the pipes, segment, pipe lengths. We can see here when we've calculated this pipe lengths, there were a couple of them that were indeed 0 meters, possibly because of a duplication in the coordinates. So I would just add an if statement in here, and I would say equals if this one is equal to 0, then the value must be 0.001. That won't make much of a difference, otherwise it must use the original value. Then I would copy this all the way down to the bottom, and there we've got it. Okay, now I can use these values in my pipes. So my pipe lengths, stop off, oops, paste it in as values. You can see there was a 0, paste it in as values 0.101. So now I can copy it again, copy it, go to my INP file, and let's paste it. So this thing is very clever. Show you where your errors are. Paste it in, remove the extra lines, save it. Let's go close it, go to EPANET again, close it. You would have to re-import the file, so I would start off with a new one. No, import network INP, open. Go into view, dimensions, auto size, there we go. And let's zoom in. Oops. Back. Add a base demand in on 500. And analyze. Run was successful. Yay. 100% flow in the pipe, 500 liters per second. So there we've got it. First analysis successful in EPANET. Now we can extend on to this. Thank you, ladies and gentlemen. That's all for today. Enjoy the rest of the day. Goodbye.